It's a pleasure to have you all back again for the next talk in the developer weekend. So I hope you all have an exciting day during Equinox Day 1, and I guess this session will only turn up the excitement more. So today we have speakers from Covalent. Covalent is a technology company that is solving the huge infrastructure problems inhibiting blockchain adoption. Their solution bridges the entrenched world of centralized databases with the new world of distributed blockchain technologies. Blockchain provides a new frontier of development for enterprises, consumers, and software developers. Due to its decentralized architecture, immutable ledger, and highly secure framework, applications of the technology will impact industries ranging from finance and retail to personal identity and cryptocurrency. Covalent solution will exponentially increase access to and adoption of distributed blockchain technologies for enterprise and consumer use cases. The first version of Covalent was built in a weekend at a distributed systems hackathon in the fall of 2017. And I guess that is the best motivation we can have for the hackathon, which will be starting real soon now. After winning the hackathon, they decided to turn it into a hosted service and started commercialization. Their team is comprised of industry veterans in database and distributed systems. Covalent is funded by leading venture investors with over a decade of expertise building and scaling technology companies. And today we have amongst us sorry for the pause. We have Mr. Ganesh Swami, the co-founder and CEO of Covalent, Mr. Rai Singhani, lead developer evangelism at Covalent, and Adam, who is a Covalent alchemist and is an old timer in the crypto community. It's a pleasure to host all of you at IIIT Lucknow, and over to you, Ganesh.
Thanks, Vinamr, for a pretty comprehensive intro. You've done most of the heavy lifting here. So I'm just going to give you a high-level summary about what Covalent is, what our path has been, and what the next couple of months and couple of years are going to look for us, and then hand over the driving seat to Harish and Adam, which is the main activities for today. So I'm a data scientist and a physicist by training. I've been in the data space for about a decade, mostly working on database technology systems. And how I spend my weekends is hacking on database stuff. So we went to the hackathon, built the initial version of Covalent. We found that there's a gap in this space where this blockchain stuff is exciting, but it doesn't really talk to existing deployments, existing investments like the talent and the people. And so you need a binding agent that connects the centralized systems to the decentralized systems. So covalent bonds, if you guys remember your high school chemistry, that's the analogy. So this binding agent is this middleware that we built. We ended up winning that hackathon and starting a company around it. And the first 2.5 years hasn't been easy. Our timing was not the best, or maybe the best, depending on how you look at it, because just as we started, the bear market hit. And for about 2 years, there was no market, no customers, no revenue, nothing. So, just two of us, we bootstrapped the company. Levi is also a database engineer. He built CouchDB, which is a pretty popular database. He built CouchDB at IBM. So we were just slinging code day in and day out, trying to figure out what to do. Just, we did that every day for 2 years. And then in mid-2020, things took an unexpected turn. Suddenly, we started closing customers. Suddenly, we couldn't keep up with the demand. Suddenly, we found ourselves profitable. And this was all very surprising. And so what we decided is, okay, we're actually onto something. And the way we are thinking about the opportunity from a commercialization perspective is there are maybe 3 or 4 breakout categories in crypto. The first breakout category are the exchanges, so the trading venues. So you can see Coinbase went public this week. Binance is a multi-billion-dollar company. One of the top companies in India, CoinDCX, very profitable, very successful. So these exchanges are very, very successful, and they're breakout categories. The second breakout categories would be something like custodians that help manage your crypto, and they hold custody of your assets. So examples of companies in that category would be Anchorage and BitGo, very successful companies. The third breakout category is the data layer. And you can look at comps here, comparable companies like Chain Analysis that raised a $100 million round just 2 weeks ago. A direct competitor of ours, which is the Graph, is at a multi-billion-dollar valuation, and Covalent falls into that in that same bucket. I would make a strong argument that we have a better product, we have a better team, we have a much more good-looking team, and we have a better go-to-market. So we fall into that bucket. So that's when we realized, okay, let's go out, get venture capital, and scale this company. So we closed a round of funding last summer, and this was a $3.1 million round with some of the top investors in the space. And then we closed the second round of funding, which was earlier this year, where both Binance and Coinbase, two of the top two exchanges, invested in Covalent. And just 2 days ago, we've announced our public sale on CoinList. So that is for the first time, we're offering essentially participation rights into the network to the broader community. So what's unique about projects like Covalent is, unlike a commercial operation, which you might be familiar with, maybe the Infosys or any of these things, blockchain systems are owned by the token holders. They participate in the system, and then they contribute to the system, and they govern the system. So that's what's unique. So for the first time in the history of Covalent, we are offering this to the retail, the public. So that sale is scheduled for the 29th. The announcement went out a couple of days ago. And yeah, so in the last 6 or 7 months, we've gone through a hyper growth phase. The number of team members has grown from 3 people to 30 people. The number of projects building on Covalent has gone from just 5 projects to over 100. The number of blockchains we've indexed has gone from just Ethereum, 1 blockchain, to about 8 blockchains today. So we've seen massive growth across all dimensions. And we are starting more programs. The Alchemist Program is an example where we're very lucky to have an experienced person like Adam join in as an alchemist. And you could think of this as a leadership development program where we are trying to give back to the system. So, so far, all we've done is taken blockchain data, which is already public, and massage it and fine tune it, and then we give it back, right? So it's not a lot of giving back from innate qualities. So the Alchemist Program is one of those programs, one of those initiatives where we're giving back to the community. And there are multiple programs there. It's not just for technical people. So I highly encourage you to take a look at the Alchemist Program. We just opened up 700 spots yesterday. So please take a look at it. You can go to covalenthq.com/ambassador, and it has all of the information. But yeah, that's basically what Covalent is about. And we'll leave the questions to the end, but I'll hand it off to Harish, my colleague, right now. Thank you.
Okay, awesome. Thank you, Ganesh, for that intro. Vinmar, thanks so much for hosting us. Hello, everyone. Namaste. It's pretty exciting to have the opportunity to present to you guys all today. And I think what's exciting about blockchain, there was a phrase that was once mentioned to me that sort of stuck. And it's basically that, the blockchain space is essentially where money meets engineering. So if you like money and you're interested in technology, this is a fantastic space to be in, because it's evolving so quickly. There's so much innovation, a lot of excitement. And so it's a great emerging technology field to get your hands dirty with and get involved in. So what I'm going to do is just talk you through a couple of our core resources to get you started with using the Covalent API. So the Covalent API is sort of an easy way to be able to pull blockchain transaction data. Blockchain data inherently can be quite messy, because you can think of this decentralized database as like a public computer where everybody can write to and talk to it. And so accessing that data can be very messy. And so the genesis, again, for Covalent was having the foresight to be able to organize this data through traditional tools like a SQL database, and then be able to surface that data in easy to access manner through an API. And so in order to be able to build quickly, the API allows you to pull all sorts of interesting data relatively quickly, which is perfect for a hackathon setting. So what I'm going to do is just share my screen here. And I am also going to share a couple of resources that we're going to talk through. And I'll just paste this in the chat here, and then maybe the team can forward this on. So we've got our API, and we've got our doc site. And so the doc site's great for getting started. We've got, again, links to our API, being able to sign up for our free API key, and then resources along the lines of our learning series, some of our campaigns that we're actively running, such as our 1 million wallets campaign that we're currently running with Avalanche, our partner. And again, the whole idea behind these campaigns is to be able to onboard maybe more traditional Web 2 developers into this new emerging Web 3 space. And so if you want a couple of good resources just to get started, even if you're new to blockchains, this is a really good starting point, because I'll sort of walk you through a few key resources, as well as our case studies and tutorials that we've got set up. But what I'll do is I'll talk you through our API docs specifically, and take a look at a few different endpoints and how they work. And the nice thing about the Covalent doc is that you can actually run all your queries directly in the browser. So even if you didn't want to incorporate these endpoints into, using a programming language or anything like that, you can actually export all this data in CSV format, put it into an Excel spreadsheet or a Google Sheet, and do some analysis there if you wanted to. So the way we've organized the API is around two main classes of endpoints, what we call our Class A and our Class B. The Class A endpoints, as we'll dive into a little bit more detail here, are essentially all the endpoints that are generic across multiple blockchains. So Ganesh had mentioned we support, something like 7 or 8 different blockchains. And so what we do is we actually offer endpoints that by simply changing a single parameter called the chain ID, you can actually access all the data around balances, transactions, decoded log events, all across multiple networks with just a single parameter change. Our Class B endpoints are what we determine, or what we call for specific projects or protocols. And so we initially started in, I think, mid 2020, where we said, all right, let's focus on sort of the top projects, DeFi projects. And that quickly, exploded over the past 6 to 8 months. So what you'll see is we got support for some of the large DeFi projects, Aave, Uniswap, SushiSwap, Maker. But what we're intending to do is empower the community to be able to build these bespoke endpoints for individuals to consume. And so we'll sort of empower and incentivize the community and surface all these different endpoints through a marketplace, so that developers who build these custom endpoints will also get rewarded for those who end up using those endpoints. So that's sort of a high-level definition. Some of the key things to note is we support multiple concurrencies. So when you pull blockchain data, and for example, with sort of token data, you're able to then translate this into a fiat currency that you might be familiar with. So we actually do support Indian rupees, for example, along with some of the more standard and well-known currencies. And also, as mentioned, typically you'll get your API responses in JSON format, but we do also offer the option for specifying a CSV format, and so you can get this in nice tabular data that you can put into a spreadsheet if you wanted to do analysis there. I'm going to start by looking at our pricing endpoints. That's generally an easy starting point, especially if you're new to the blockchain space. And we're going to look at getting historical prices by ticker symbol. And so again, in the interface here, I should mention that you would need to sign up for your API key, and then you're able to make the queries directly from the docs. And again, going from our docs page, there's links to signing up for our free API key. So let's take this endpoint as an example. So what we're going to do is for a particular token, we're going to get the historical data from a specified starting date. And we're just going to also specify our quote currency. And so as mentioned, you can actually, get this data. We'll just run this here. We'll hit try. And so we get this data in our JSON format, and you can see this is just broken out day by day. And we can also specify this if we want as in a CSV output, and we can get this data in a format that we can quickly copy and export into a spreadsheet if we wanted to use that. So we've got a handful of different endpoints around pricing. You can get it by a ticker symbol, just like we specified here. For those of you who might be familiar more with the concept of these token contracts, you can actually use the contract address itself or a multitude of contract addresses, and then be able to make a similar call where you're fetching the historical prices for a series of different tokens. We mentioned that we support multiple chains, and so this is essentially the parameter that you would be adapting to be able to pull data from different networks. And we kind of give you a little snapshot of the different networks that we support and the corresponding chain ID. So if you're using sort of what we would say is probably the most public and most well-used network, the Ethereum mainnet, that uses a chain ID of 1. We also support Polygon, which some of you might be familiar with, formerly known as Matic. And so you would just provide a chain ID of 137 to be able to interact directly with that network, and so on and so forth here. If I go back to the docs page, we actually have a list of all our supported networks and the corresponding chain IDs. And again, all you have to do is just switch the number, and you're able to pull data across different networks. Now I'm going to take a look at some of our Class A endpoints. And again, these are the ones that we mentioned are generic across multiple networks. And we'll take a look at what we can do with some of these. So here we have our token balance for an address. And so if we're looking at the Ethereum mainnet, we can actually provide the just the alias. The Ethereum name service will actually translate something like demo.eth into the underlying wallet address, and then be able to retrieve all the assets associated with an address. So if you haven't got a crypto wallet, very easy to do so using, for example, an in-browser application like MetaMask. You can just install it as a Chrome extension, and then you can actually go ahead and test out an endpoint like this and sort of see if you're able to pull balances for your particular wallet. Some of you might be familiar with the concept of NFTs. NFTs are a space that have just been absolutely exploding of late, which again, NFT standing for non-fungible tokens. So these are sort of collectibles. And we provide this field here that allow you to get really granular, detailed NFT data around these two token standards, ERC 721 and 1155. This isn't something that you'll get from other tools that exist in the ecosystem. It's something that's fairly unique in terms of our level of detail that we're able to provide from these very simple interfaces. So if I were to just take a look at what our demo.eth wallet has, we can see that it provides us a itemized list of all the tokens, the balances, the quote rate in your particular currency, and then if there is any NFT related tokens that exist in the wallet. Let me see if I can quickly scroll here to find one. We've got more granular data around that NFT, where we specify, some of the external metadata around what makes up that NFT. So here's one here, the I'm back NFT token. And so you can see that we've got some of the external data associated with like a name, description, the image itself, and all the key data, including the owner of that particular token, which would be this wallet. let's take a look at our changes in token height. So this is a very popular one because what it enables you to do is for a particular token, you're able to get all the token holders from any given sort of starting point or block height. And this is something I don't think any of our sort of competitors or other tools in the ecosystem would be able to provide you with as easily as you can with this API. And so what you would simply have to do here is, let's say we are looking again at the Aave token. If I am looking at this on the Ethereum mainnet, I'm using a chain ID of 1. I'm just going to grab the contract address for the Aave token. If you are familiar with tools like Etherscan, you can just simply search for Aave here, and you can get the token address. This is the one that I copied over. So Etherscan is sort of a nice tool to be able to, for the Ethereum blockchain, to grab a lot of pertinent information that you can then use in the API docs to be able to really pull more granular, detailed information. We're just going to specify a particular starting block here. And so now I'm going to grab all the token holders. This might actually take a while because there's a lot of token holders for Aave, but this is sort of the past example of the query that I made, the response, and we're getting the full list. What's great about this particular endpoint is, let's say I wanted to get all the Aave assets, all the token holders from a different network like Phantom. All I do is just simply change this to the particular chain ID. And then there's usually a mapping between the corresponding token on Ethereum and then that similar token that is on another network. It would be ideal, of course, if the address was exactly the same across multiple networks, but that does not exist. Here's an example of what the token mapper looks like. So this is for between Ethereum and Matic, where you've got your list of very popular tokens and then the corresponding Ethereum Matic conversion here. So you would just use the corresponding address if you were looking at the same asset across, a Matic network, for example. Let's just have a look at our NFT endpoint. So from the token wallet balance, you can fetch all the NFT, but we've also got dedicated endpoints specifically for grabbing detailed information around a non-fungible token. And so the first one that we can do here is we can take a look at all the token IDs associated with an NFT contract. And so one way to get the particular address to be able to then find all the token IDs is you can go to a marketplace like OpenSea. And so whenever you look up an asset on OpenSea, it will give you the corresponding contract address that you can then use in the API doc. So here we're looking at these NFTs called Axie Infinities, these little cute looking things. And so if I search for all the token IDs associated with this contract address, we'll get a response that's got a list of all the tokens and even a little logo for each one. And then using that data, you can actually go and iterate through a particular token ID and get all the NFT transactions associated with that particular token, as well as a whole host of external metadata also associated with that token. So you would start by getting a particular token ID or a list of all the token IDs, and then be able to look at the transactions or the external metadata as well. So that's just a feel for our Class A. We're actually going to get Adam to talk a little bit about how you can do even a further deeper dive and be able to look at things like log events. So every smart contract, whenever there is a transfer of tokens or a sale of a particular NFT, all of those events emit what we call log events. And those log events then get sorted by something called a topic hash. So it's just a way to be able to filter and identify a particular type of log event. And so in his example where he talks through creating a visualization, he'll talk a little bit about the log events and log events by topic hash. But just before we get to him, I want to talk very quickly about our Class B endpoints. So as mentioned, these are very specific for certain projects. So if we take a look at SushiSwap, for example, we can grab all the network assets for SushiSwap, for example. So I'm just going to, again, this is going to be on the Ethereum mainnet. So we use a chain ID of 1. And so if we take a look at what we get back at a response, these are all the pairs that are being traded on SushiSwap. So this is the exchange identifier. And then you've got information like the swap counts, the total liquidity, and then the swap pair. So the token 0 is this USD coin, and the token 1 is the wrapped Ether. And so every single exchange pair that exists on SushiSwap can be accessed right here with one API call. And then adding to this, if you wanted to get all the SushiSwap assets from, let's say, the Phantom network, we'll just simply change the chain ID here. And now we'll grab the exact same, we'll grab all the all the exchange pairs from a completely different network by just changing that one parameter. So here we've got our wrapped Phantom pair tokened with paired with the ICE token. So these again are all the swap pairs that exist for SushiSwap. And you get the same information for Aave, you get the same information for Balancer, Uniswap. We provide all that detailed granular information for a particular protocol here, the large protocols, I should say. Okay, I know we covered a lot. You probably wouldn't, maybe, some of this hopefully sunk in. Again, we've got our docs page where we go through a lot of these examples and will hopefully be a good resource for you to use to be able to digest some of this information a bit more. But with this, I'll pause and let's bring in Adam to now give us sort of a walkthrough of what an Alchemist ambassador experience is like, and then also about his work putting together a data visualization using the Covalent API.
Awesome, thank you, Harish.
There's a question by the audience, like one question. That how is Covalent different from Graph protocol?
There's a lot we can say here. I think Ganesh may have pointed this out very briefly, but Ganesh, do you want to walk through maybe a few key points around the difference between Covalent and the Graph? Because I know you do this almost like every 30 minutes.
Absolutely. So the key difference is that Covalent has made an exact replica of the blockchain into a database. So we have every single balance, every single transaction, every single storage slot, everything that's visible in a blockchain. We've copied that to a database. And then the API sits on top of the database and is able to answer queries and is able to answer questions. So all of this is automatic. So for example, if you take a look at one of the Class A endpoints that Harish shared, give me the list of your ERC20 assets. That scans every single ERC20 contract on the blockchain and finds out if you have a non-zero balance. So that's how that system works. In the case of the Graph, what they do is you have to write a subgraph. So first you need to find an engineer. Second, you have to invest maybe a couple of days to write a subgraph, which precisely answers a question that you might have. And then you deploy that subgraph, and then that subgraph copies out the answers to your question into a database, and then you query that. So if you need to ask a question that's outside that scope of that subgraph, you have to go back and remodify and rebuild that subgraph and then resync it and reindex it. There's a lot of process there. So fundamentally, that's the core difference. So there's some kinds of features that you can never do with the Graph, like give me a list of your historical transactions, very important for taxation. Give me a list of all of the NFTs. So they still don't have an NFT subgraph. They can never build an NFT subgraph because it's too big, it's too much. So the only approach is to do something like Covalent. And of course, on a faster blockchain like Binance Smart Chain, the Graph's approach just falls apart. So Covalent today is the only option for faster blockchains like Binance Smart Chain. So you can take a look at PancakeSwap. which is a Uniswap clone on Binance Smart Chain. And they've just opened up a bounty for $150,000 because the graph has fallen over.
Maybe one quick thing to add to that. One way I like to think about it, I know Ganesh, you've used this analogy several times. Think of Covalent and the underlying data as just being a giant Excel sheet. So every wallet balance, every position, every transaction, everything that we've indexed is available for you in a giant Excel sheet. Whereas if you're trying to use the graph, the data only exists once that subgraph is written. And so you get, it's a much more difficult experience when you only get access to the data once that subgraph is written after you've invested the engineering resources. Whereas with our giant Excel sheet analogy, all that data is available for you. You're simply just creating pivot tables to then pull the data that you want for your use case.
I guess that would have answered that question pretty well. So I guess now we can ask Adam to take over the show.
Awesome. Super excited to be here. I guess I can start with a quick introduction, how I found Covalent and how the Alchemist experience has been for me so far. So I've been involved in the cryptocurrency space for probably since like 2013 or 2014. My day job by trade is I'm an ML engineer at a data annotation company. And one of the things I noticed in blockchain was that it was really hard to get high quality data easily. So I guess over the past 1 to 2 years, I was sort of searching for a project that could do that. And to my excitement, Covalent first appeared on my radar back in the fall of 2020. And ever since then, I've just been using it for my own research and development. So really excited to show you guys sort of a quick overview of how you can use the get log event by topic hash endpoint. So I'm going to walk you through the protocol we're going to be looking at, as then dive into a Jupyter notebook and sort of how you can implement the endpoint and wrangle that data that the endpoint gives back using Python. So I'll go ahead and present now. And can everyone see my screen?
Yep, can see your screen now.
Awesome. So today we're going to be looking at Aave, and that's because Aave is arguably the largest DeFi protocol in cryptocurrency today. You can see that they currently have about $7 billion locked up across their different markets. In particular, Aave offers a very short-term loan that's called a flash loan. So we're going to be examining the Aave V2 contract today to see how many flash loan events have been emitted on that contract. So the first thing you want to do is go to Etherscan. You want to find the contract address for the Aave V2 lending pool here. You're going to copy this address, this button right here. And as Harish mentioned, you can navigate to the Covalent docs and use the topic calculator. I've already pasted it in here to sort of speed things up a little bit. And once you paste this in, you'll see here that this is every event that the Aave V2 lending pool contract emits. So for our purposes, we're going to go here and we're going to copy the flash loan event. We're going to go back to the Covalent API documentation, and we want to navigate to the get log events by topic hash. So since we're on Ethereum, we want to set the mainnet, the chain ID to 1. And the topic, this is where you're going to paste the topic hash that you got from the Covalent topic calculator into here. For the starting block, usually I like to start with the block that the contract was created. and I'll show you how to get that right now. If you go back to Etherscan and you go here, you can see it says contract creator here. So this is the address that created the contract. What you want to get is the TXN hash. So that's going to tell you the block that this contract was created. So if I click here, I can see that this contract was created at this block. So we're going to copy this, go back, paste it into the starting block. For ending block, I believe that the Covalent API currently handles about 1 million blocks at a time. So once we get into the Jupyter Notebook, I'll show you a way that you can iterate through multiple sets of 1 million blocks at a time. So for now, we can just set this to 1 million from here. Sender address. This is the smart contract that's emitting this event. So we'll go back to Etherscan. We'll copy that address, paste it in here. Format. If you prefer CSV, you can type in CSV here. So I'll just paste that there for now. And we'll hit try. So you can see the response that we got. A lot of data in here. I'm going to show you how you can quickly clean all this data up. So this is what we're going to want to grab and paste into our Jupyter Notebook. So I'll quickly switch screens. So now we have our Jupyter Notebook open. We're going to be using the requests, pandas, NumPy, JSON, as well as the web3.py library. So first, I'll create a pandas data frame. Here is where I talk about how you can quickly iterate through a large number of blocks. I'll create a list for the starting blocks, as well as a list for the ending blocks. I'll then create a for loop and zip these two lists together. Here is the GET request to the Covalent API. So you can see here is the topic hash for the flash loan event. Here for starting blocks and ending blocks, I've left them open. Setting the page size to a large number, as well as the sender address. That's going to be the Aave v2 lending contract, the API key. And now you can see then that we're formatting for the starting and ending block list that we created. So I'm going to grab that result, the JSON as that result, and name it data. We'll then put that into another data frame, and then append each iteration.
Adam, can you zoom in to the notebook?
Yeah, sorry. Is that easier to read?
A bit more, I guess. Yeah, that looks.
How's that?
Yeah, that looks good.
Okay, great. We're then going to append the results from this data frame to the original data frame that we created. I'm going to set, just because I've seen it before, I already set the index prior to looking at the data frame. But if we look at the data frame, we can see that we have a lot of data here. We have the block signed at, the block height, the TX offset, the log offset, the TX hash, which is the hash of the event, raw log topic bytes. And if you scroll over to here, you'll see this column called decoded. So this is all of the information of that flash loan event that was emitted. This will include the smart contract that called that flash loan function, as well as the amount that was requested in the flash loan and the cryptocurrency that the user wanted to receive in their flash loan. This can be something like USDC, ETH, or DAI. It's just depending on what that smart contract wanted to call at that time, as well as the fee that the protocol charges for that flash loan. So this is dropping a column. I believe I'm dropping the raw log topic byte column here just to make it a little bit easier. Quickly checking the TX hash column just to make sure I can see all of them. Viewing all of the column names. Then I'm going to set that decoded column to a new series. All right, well, I already have this, so just ignore that. We're going to be sending this into a CSV. We would read that CSV into a new data frame, set this again. Here, I'm then splitting, and I can splitting all of the information in the decoded CSV to make it a little bit easier to clean. For the purposes of time, I'm just going to go ahead and go to the cleaned up data frame that we'll be doing most of the wrangling on. Great. So you can see these are all of the different values that were in the decoded column that we've now cleaned up. You have the target, which is the smart contract that is calling the flash loan event. The initiator, that's the address that created the flash loan, but we're going to be focusing mainly on the target for our analysis today. The asset, and you might be wondering, why is the asset a Ethereum address? Don't worry, we have a way to clean that up. The amount, these amounts are either in 18 decimals or 6 decimals, so we will also clean that up. If we go here to reserve values, I've created a dictionary that maps each Ethereum address to its corresponding symbol, and you can get all of these addresses from the Avi documentation. Now if we, okay. All right, I'm not sure, 1 second. This may have already mapped. I'm not sure. We can ignore that for now. I'm sorry about that. Here we have the functions. These two functions here are utilizing the web3.py library. Moe is for 6 decimals. So here this is saying take in X and change it to Moe. And for here, take in X and change it to Ether. So once we run that transformation here, you can see that we now have the assets changed to the correct symbol. And the amounts still haven't changed yet. So to iterate, to map these values out to the correct decimal values, I've created 2 different lists, one for the assets that have 6 decimals and one for the assets that have 18 decimals. So here we're going to use the np.where function to create 2 new columns based on this condition. So this is saying if the asset is in this original list, map these 2 columns with this function. Otherwise, map these 2 columns to this function. And you can see after we apply this that we now have the amount as well as the premium charged by the protocol in a more readable view. We'll then drop the 2 columns that we don't need and rename all of the columns here. And this will create this data frame here that's nice and readable. We have the target again, the initiator, the asset, the amount, and the premium. Going back to our original data frame, we want to check in again to see which columns we want to use for our analysis. For the purposes of my analysis, I dropped the following columns. Checking the data frame again, it's a lot shorter now and a bit easier to read and view. We then concat those two data frames together into our final data frame here. So you have the block signed at, the block height, the TX and log offsets, the hash of the transaction, and then all of the values from our original decoded CSV here, the target, the initiator, the asset, the amount, and the premium. So for my data analysis that I wanted to do, I wanted to look at what smart contracts were calling flash loans the most. So to do that, I exported the value count of the target column into a new CSV. I did this both for Aave v1 and Aave v2. And the main purpose of this was to compare the number of flash loans provided by each of Aave's two versions of the lending pool, mainly to gauge the growth and distribution of flash loans as users migrate from Aave v1 to Aave v2. So now I'll quickly switch over to the Tableau visualization that I've created.
I know that was a lot of detail, but the end result is worth it.
This is easier to understand. So you can see here on the left, we have Aave v1. And on the right is the data that we just worked with, Aave v2. So comparing the two of these, you can see that in Aave v1, we had two targets that seemed to be calling the flash loans. But we also had a lot of noise here. It seems like there were a lot of smaller accounts calling maybe 1 to 5 flash loans, not really a measurable number. Whereas when we look at Aave v2, we can see that it's a lot more concentrated with a couple of accounts and not as much noise. And so one reason for this may be that, yes, the Aave v1 lending pool is older than Aave v2, so that's why we see more action with Aave v1. It also may be that for Aave v2, perhaps people don't like using the Aave v2 lending pool for flash loans, or it's just more centralized around a couple of users. If anyone has any questions, I'm happy to answer them. I'm also happy to share the code that I walked through as well, if you would like that.
Yeah, there are 2 or 3 questions. So, can Covalent API work like the TWAP Oracle for SushiSwap and Uniswap? They get info about all the players made on these dexes. I'll again post it in the chat also.
Sure, I can. Do you want to take that, Harish, or do you want me to take that?
Yeah, go ahead.
So are you asking if it's possible to look at all of the events for Uniswap or SushiSwap? Was that the question?
Yeah, I would interpret this as like, getting all the detailed pair information made.
Yeah, totally. You can do that. A good place to start would probably be the router contract for either Uniswap or SushiSwap. You can go back to Etherscan and just look up Uniswap router. Uniswap also has that in their documentation. And then, just like we did before, I would take the Uniswap router address, I would put that into the topic calculator, and then you can look for the different events that are going to be emitted by the contract.
Yeah, and maybe just to add to that, so I talked about in the API docs, we've got dedicated what we call our Class B endpoints for all the major Uniswap and their clones. So Uniswap, Pancake Swap, Sushi Swap, those are all dedicated endpoints where you can pull in all the pairs that are made on that DEX.
I actually heard about a clone of Pancake Swap being deployed on another blockchain. So they're now clones of clones.
Oh my God.
Second generation clones.
Clones of a clone.
So there's another question. I'll again
Sure.
post it in the chat for your reference. Things like relative price info and slippage after a trade is done.
So for that, I would need to look at the contract itself.
Yeah, generally with like these swaps, we've got something called a sync event, and using the two tokens that are associated with that sync event, you basically get the spot price for what that trade executed at. So there is that dedicated log event that we've got called the sync. And that's how you can actually get the actual execution trade price for that particular pair.
So these were the questions from the audience as of now.
Great.
So I guess will we be continuing or Adam?
Yeah, I mean, there's just a couple more things, Ganesh. I think you had mentioned about our ambassador program. Is there anything else that you'd want to highlight for the audience?
So we run a lot of these hackathons. And so I would highly encourage you to partake in the hackathon. The purpose of these hackathons is not to win. Winning is just a side effect. The purpose of these hackathons fall under the umbrella of something called proof of education. So if you're learning and you're able to build, you're able to contribute, you're able to judge, you're able to participate, that in itself is winning. So we have the 1 million wallets that we run. We have the Scaling ETH Global event that's starting today, actually. And then we have one with Ivan on Tech. And then we actually just wrapped up Dungeon Data, which is a data hackathon with Aave. And one of the exercises was what Adam showed.
So
Cool.
Ritvik has a question that what kind of wallet would you want the community to build for the hackathon? What are you expecting from the community?
I could take that, Ganesh, if you want. I know you've got several ideas that you'd love to have the community build. So I mean, what's exciting about the 1 million wallets is that it's basically designed to like unlock and unleash the creativity of the community. Generally, what we see as being sort of popular hackathon projects revolve around creating multi-chain dashboards. So imagine being able to see all your assets, sort of a trend of maybe the portfolio value of those assets, but not just locked into one chain, but having this across multiple chain if you've got assets across different networks. We've talked about things like taking your NFT collection, maybe creating some sort of background or screen, sort of a screensaver around that maybe plays to certain music depending on that particular NFT. I know that was one Ganesh likes to highlight because that's a really cool idea. We've talked about building out dashboards, and I think Ganesh can talk a little bit more about this because this was one of his great ideas, was around just having a financial tool for DAOs. So these these decentralized autonomous organizations who've got a broad range of community members. How do you organize them from the perspective of managing the finances of the DAO? So everything from multi-sig to governance to all those key components, and just having a tool which enables you to manage your DAO effectively. And then, we've got, trading bots. We've got Discord, Telegram bots that surface up everything from spot price information to transaction history. There's no limit what you can do with this data. And what's exciting is, there's tons of use cases that we even haven't thought up, and to see what the community comes out and builds.
So as you can see from live chat also, people were really excited. Shlok is saying that he just checked out Covalent's API and is super stoked to use it. People are saying that this was super awesome and they're appreciating the job you guys are doing. So to end this session, thank you all for coming. It was a pleasure to host people like you for this, and I guess the main thing our hackathon also wishes for is that people learn something new. And this session was all about learning new things in just such a short duration. And also just to inform you guys, uh, in the hackathon there is a track by Lumos where you can build your own crypto wallet the way you want using the code templates and easy to use APIs from Lumos Labs and win from a pool of 15,000 USD in AVAX. So go read about the documentation, and we'll be hoping to see some amazing hacks. And as you all know, the hacking period has now begun, and looking forward to some amazing hacking. Let's stay connected on Discord, and thank you for joining in, and thank you all of you for giving us your time. And I'll share the Discord link.
Posted our link to our Discord, so any developers who've got questions around our API, please don't hesitate to ask in our Discord channel. We've got an army of support staff who would love to help you out with your ideas and any issues you might have.
Indeed.